Hello everyone, today we will share modification of chip antenna. It is a function expansion board of AIPi. It uses the RA08 module on it. And the antenna is an SMA head, a pepper antenna transferred. Some users think that this antenna does not look good when exposed outside. Then it will affect the overall appearance of the product. Today we'll try to transform it into a smaller chip antenna. This modifying process doesn't mean that its performance will surpass the antenna of this small glue stick. But it can be completed under the premise of meeting this performance to make the whole product more integrated and even more beautiful. Let's start with this. Why do we need to do some manual alterations? Because this antenna is made of a connector with an elbow like this. The SMA connector consists of such an adapter. Then this adapter peripheral here is copper. It has no clearance. The using environment of the antenna. There should be some space on the main board to clear space of the antenna, that is to say, copper cannot be laid. We'll blow this joint off with a heat gun, and then put this copper foil on this surface. Scrape them off, one by one. Then connect this antenna with this RF port of this module. You may want to ask, what are the advantages of chip antenna? In fact, there are two main advantages. The first thing is that it looks smaller. It can be integrated and can be hidden. The second thing is its cost will be lower. As a consumer electronic product, almost all products can be applied to chip antennas. Although the chip antenna cost has advantages over others, and its volume is also smaller, there still are some drawbacks. The main one is its small size. It can't possibly achieve a very extreme performance. And as the chip antennas exist in the form of on-board, in the face of electromagnetic interference of the board, it will be more sensitive than external antennas. So in some cases, it doesn't necessarily work with this chip antenna either. For example, if your whole machine is fully metal shell, then you must only use this external glue stick antenna. So when we are choosing which antenna model to use, it should also be based on the form of the product. If you think the noise on the main board would be more complicated, just try not to choose this type of onboard antenna. It's mainly applied to something that has strict requirements on volume. For example, like some Bluetooth headphones, and some small anti-loss devices. We should choose the antenna type according to the actual project situation. Now I've taken care of the headroom environment for the antenna. I put this copper foil on both sides. It's the copper foil around the bottom of the antenna. A headroom area was treated by hand. And that's about the size of the clearance area. We can ignore the pads of the original sockets. Now we need to look at this radio frequency port. To make a jig lead from the radio frequency port. And then can better measure the passive parameters of the antenna. Tuned to the frequency band we are adapted to. The current operating frequency of this module is 433 MHz. Then when we adjust the antenna, we need to set the resonance of the antenna to 433 MHz. Okay, we've already adjusted that antenna. This is where the antenna is assembled. And the above is a match of its concatenation. What about the disconnected microstrip cable here? That's what we use to connect the fixture wire to see it. S11 parameter. We're going to hook it up to the meter. Take a look at its return loss. We have adjusted the antenna. We are now at its central frequency, 433 MHz. Its return loss is -21.7. We can take a look at its standing poppy. Of course, this can actually be converted. If we don't look at the resident bobby, we can calculate the current bandwidth of this antenna. To look at its standing poppy, what is the approximate bandwidth of less than 2 MHz for 24-442 MHz? That's about 18 MHz of bandwidth. Finally, we have finished the commissioning work of remodeling this piece. In conclusion, the yellow area of the antenna is where I scraped off the copper foil. This is what we name it the clearance area of the antenna. It's from the top floor, bottom layer. And in the inner layer region, copper cannot be laid. Only the pads of the antenna. And this RF, this microstrip line. It can be laid with copper. Then this is the installation position of the antenna. It's between this area where copper can be laid. It has a height. This height determines the performance of the antenna. And the chip antenna acts as a standard antenna. It's usually used as this matching network. To do some frequency tuning and some compensation. And this thread is a jig line to be welded when we measure passive parameters.